You know, it's something you do probably hundreds of times a day without giving it a single thought. But have you ever wondered what's really going on in that tiny fraction of a second right after you click your mouse? Well, today we're going to follow that click on its absolutely incredible high-speed journey deep inside your computer.
I mean, really, think about it for a second. You click an icon, and poof, a program just appears on your screen. It feels like magic, right? But it's not. It's actually a lightning-fast, perfectly choreographed dance between all the parts of your computer. So let's pull back the curtain and see what's actually happening in that blink of an eye. Okay, so before we can actually follow that click on its big adventure, we kind of need a quick lay of the land. We're just going to start with the absolute fundamentals of what makes a computer, well, a computer. When you strip everything else away, this is all a computer is. It's a machine that's built to do four basic jobs. It takes stuff in, it thinks about that stuff, it remembers it, and then it shows you the result. That's it. Input, process, storage, and output. That simple four-step is the blueprint for everything from the phone in your pocket to the biggest supercomputer on the planet. Think about it this way. The entire computer world is basically split in two. On one hand, you've got the hardware. That's the physical body. It's the stuff you can actually touch, like your monitor and keyboard. And on the other hand, you've got the software. That's the mind. It's the invisible set of instructions, kind of like the ghost in the machine, that tells all that physical hardware what to do. One is totally useless without the other. And here's the whole point of a computer, its main purpose in life. It takes in raw, kind of meaningless data, just a random jumble of numbers and symbols, and it processes it into useful information. It's like turning a random pile of Scrabble tiles into a perfectly formed sentence. That transformation is the computer's real magic trick. And that brings us right back to our click. That little action is the very first step in that whole four-part process we just talked about, getting data in. This is the exact moment we send the first signal into the machine and kick the whole thing off. Yeah, that click is so much more than just a physical action. In the world of the computer, it's a piece of data. It's a command. It's an input that basically shouts at the system, hey, wake up, it's time to do something. So how does that shout get heard? Well, it's all thanks to an input device. The best way to think of it is as a translator. It takes your very human action, pressing down on a button, and it converts it into an electrical signal, a special language of ones and zeros that the computer can actually understand. And your computer is full of these translators. Your keyboard translates your typing. A microphone translates the sound of your voice. And for our story, the mouse is the one translating that physical click into a command. It's that one little signal that starts this entire journey. Okay, so the signal from our click is officially inside the machine. Where does it go? Well, it goes straight to the top, to the nerve center, the main headquarters, the part of the computer that does all the real thinking. And here it is. Meet the star of our show, the Central Processing Unit, or just CPU for short. If a computer has a brain, this is it. It's a tiny little chip of silicon packed with millions of microscopic switches that all work together to figure out what that click means and what to do next. Now, this brain has two main parts. First, you've got the control unit. Think of it like a director on a movie set. It reads the instruction from our click and then starts bossing everyone else around, telling them what their job is. Then you've got the arithmetic logic unit, or ALU. This is the math whiz. It's the super calculator that does all the math and makes all the logical decisions needed to get the job done. But hey, even the smartest brain in the world needs a desk to work on, right? That's RAM. It's an incredibly fast but temporary workspace. When you click to open a program, all the important bits get loaded into RAM so the CPU can get to them instantly. And that speed is everything. It's the difference between your computer feeling snappy and responsive or slow and frustrating. And this brings up a really important point. RAM is like your short-term memory. It's super fast for what you're doing right now, but it's also volatile, which is a fancy way of saying it gets wiped clean every time you turn the power off. Then there's ROM, or read-only memory. That's more like permanent memory. It holds all the really essential instructions your computer needs just to wake up in the first place. Okay, so let's do a quick recap. The click has been received, the CPU has done all its thinking with the help of RAM, and now it's time for the payoff. It's time for the computer to actually show us what it's done. All that complicated internal thinking and processing is now getting converted back into something we can actually understand. This is step 3 of our cycle, output. The computer is finally ready to talk back to us.
And how does it talk back? Well, it uses an output device. This is literally the exact opposite of an input device. It takes the computer's language, all those ones and zeros, and translates it back into something we can see, or hear, or even read. So, in our story, the grand result of that first little click is the program window appearing right there on your monitor. The monitor is the output device. Now, if you'd clicked on a music file, the speakers would have been the output. It's the grand finale of all that hard work. Our journey is almost complete. We've gone from input to process to output. But hold on, there is one last absolutely critical function that we need to talk about. Hey, remember how we said RAM has a terrible memory, that it's volatile and forgets everything the second the power goes out? Well, that's a pretty big problem if you've just spent all afternoon writing a paper or creating some art. So, how does a computer actually remember stuff for the long haul? The solution is a totally different kind of memory, secondary storage, like your hard drive. So if RAM is the messy, temporary workbench you're using for your active projects, the hard drive is the big, permanent filing cabinet where you store all your work when you're done. Okay, so let's zoom all the way out. We just followed one single click through these 4 basic stages: input, process, output, and storage. But here's the truly powerful part. That exact same cycle is what powers every single computer on Earth. It doesn't matter if it's a tap on your smartphone screen, a command someone types into a huge server, or an instruction sent to one of the most powerful supercomputers in the world. This same fundamental process is happening over and over again, just at wildly different scales and unimaginable speeds. And speaking of speed, you might want to sit down for this. A top-tier supercomputer can perform 1 quadrillion calculations. That's a 1 with 15 zeros after it every single second. Our humble little click is just one of quadrillions of things it can handle in the time it takes you to blink. It's just insane. So why in the world do we need that kind of mind-boggling power? Well, we use it to tackle humanity's biggest, most complex challenges. We're talking about things like accurately predicting where a hurricane will go, simulating how nuclear reactions work, or even mapping out the entire universe. These are problems that need a massive amount of brain power. So, when you think about it, the journey of one simple click reveals the fundamental logic that scales all the way from your desk to solving the world's most complex problems. And it really makes you wonder, doesn't it? If this is what today's machines are capable of, what incredible questions are we going to be able to answer tomorrow?